Good afternoon, students. Today we are going to discuss about the experiment number 3, whose title is to write VHDL code, simulate with test bench and synthesize of first in first out memory. So which is called as FIFO memory. Okay. So this FIFO memory is always a temporary memory. Now, as everyone knows that we should give some specifications to this memory. Right now, we are going to design a 4 by 4 size of your memory, wherein this first 4 indicate that how many bits you are going to write or read from one location. So this 4 indicates we are going to write or read a 4 bit of your data into your the memory or from your the memory respectively, right? So this for first 4. Now the second 4 indicates the total number of locations. So we are going to consider the total number of locations are equal to 4. So that's why we are going to consider now the size of your memory is 4 by 4 memory, which stands for there are 4 locations, and on each location we are going to read or write 4 bit of data. Okay, so which is nothing but your the memory. As everyone knows that this memory is always used to read or write your the data. Now if you can see here, always there is a one input is required, which is data in. It is of 4 bit. Right now we are going to specify it is 3 down to 0. Next one is we required a clock signal. Similarly, there is a need of your read signal is required. When read is equal to 1, we will read the content of your the location. Okay, so that is nothing but the read content will be available on this output signal, which is called as data out 3 down to 0, right? Now there is a one reset is there. So once your the memory block is reset, is nothing but this data out is initialized to 0 0 0 0. Okay, then next one is your the write signal. When write is equal to 1, in the sense that on all these locations, means if write is this signal we are going to make it 1, means we are going to write into the each location one by one by using this your write signal. Next one is there is a empty is there, which indicates that your memory is empty or not. Okay, so when empty is equal to 1, it indicates your memory is empty. When full is equal to 1, it indicates that your memory is full. Apart from these signals, we are going to use additional 2 signals, which is nothing but the head and tail. So what is this head and tail? Head indicates that your memory is full, while tail indicates that your memory is empty. Okay, so head will be here we are going to use, as everyone knows that there is a queue you are going to consider, okay, in a data structure. So similar to this queue, by using the head pointer, we can write into your the memory location. Okay, when head is indicating it that we are going to increment the counter by using the head, which indicates the write operation. By using the tail operation, we will indicate it that we are deleting or popping out the content from your the memory, means we are reading the content from your memory, which is nothing but the tail. So in this way we are going to use these different types of your input output signals for your FIFO memory. Now let us we will write a HDL code for this FIFO memory using Xilinx software. So you have to double click on this Xilinx ISC design suite. Now you will observe here. Are you able to see the students? Let me know. Are you able to see the code? Yes, please. Anyone? Students, are you there with me?
Yes, ma'am.
Okay, thank you.
Yes, ma'am.
Now you can observe here in this case, as in your ALU design also, we have used some library declaration, additional use of your the package you have added. Similar to here also, as you are considering this FIFO memory, means we are going to create some temporary memory and we are going to perform some reading and writing operation into this your memory. So by considering this, here is a library declaration, that is library IEEE. Then you are going to use this IEEE ST logic 1164 package. So along this package, you have added the additional two packages. One is your arith.al, that is STD logic arith.all, and the second one is STD logic unsigned.all. So these two packages are required to you as we are going to perform some integer related operations. So that's why we have added this std logic unsigned.all for while reading and writing your the memory. Now you can observe here under the entity declaration, there is an entity name is given, and there is a port. In the port you can observe this clock, reset, read, write and data in. So these are the different signals are used as your the mode of these signals is a in mode, and is each is of std logic type. This data in is of vector type of size 4-bit. Okay. Now there is a data out is there, which is of std logic vector, again 3 down to 0, which is mode is out, and then to indicate whether the memory is full or empty, again it is of out, mode is of your this, both these signals will be the out, and then type is its std logic. Then end of this your entity name. So in this way we have declared the entity here for the FIFO memory. Then followed by in the architecture, you can observe here in architecture that we have to consider here a process statement. Okay, so in a process statement our sensitivity list is your the clock signal. So once there is a clock is there, then you are going to declare a user, means you are going to create a user defined memory here. So that's why you are going to declare a user defined data type as your FIFO memory, and the size of this your FIFO memory you are going to mention here as 0 to 3, which is nothing but it is an array 0 to 3, which will indicate the total number of your locations of std logic vector. On each location you will write a 4-bit of that data, that's why it is 3 down to 0. So in this way we have defined here a user defined data type, that is you have created your user defined data type as FIFO memory of size 4 by 4. Next one, you are going to declare here one variable which is nothing but a memory whose data type is of user defined data type FIFO memory. Okay, you have created here the memory, that is it is whose data, means we are declared it as a variable. Okay, and its type is FIFO memory, right? Next is we are declared here two variables as I already discussed previously, that is head and tail, and this head and tail is going to indicate the location 0 to 3, because the total number of locations in a memory you are going to consider 4 by 4, that is total 4 locations are there. That's why head is nothing but for writing purpose and tail is for your reading purpose. Okay, to pop out your the data from the memory, we are going to use this tail. Then apart from this we are going to add here one another variable which is a looped variable, and we are declared this as a boolean. So I will explain you why this looped is used here, and it is of type of boolean. Okay, now next one is here, now there is a begin of your this process statement, in which initially either you can use clock is equal to 1 and clock tick event, that attribute either you can use, or you can use directly user means inbuilt function for detecting the rising edge of your clock. Now I am going to use here if rising edge, which is a function, inbuilt function. So rising edge of your clock will occur. Then we are going to again check for the condition, if reset is equal to 1, then you are going to initialize these variables, that is the location of memory, head and tail. So head will indicate that is memory of 3, that is the topmost memory. Tail will indicate the lowest memory, which is memory 0 always. Okay, so this if reset is equal to 1 and rising edge of your clock occurs, then head and tail you are initializing 0 and looped is initialized to false, as it is a boolean type of variable, means either it will false indicates it is 0 and true indicates it is 1. It will store these two values. Then you are going to initialize initially as reset is equal to 1 means memory is empty. So that's why empty is equal to 1 and full is equal to 0. So this is the first initialization sequence you have considered with the rising edge of your clock and when reset is equal to 1. Okay. So is it clear, students, this one? Let me know. Yes, please. Are you there? Yes, everyone is there.
Yes, ma'am.
Okay. Yeah.
Yes,
Yeah. So next one is here the else part. In else part, you are going to see first the read operation. So in the read for the reading from the memory means always everyone knows that you can see the content by using the read command. Okay. So if read is equal to 1, then you are going to set some condition here. What is that condition? Is that looped is equal to true or head is not equal to 10. When we say head is equal to 10, then at that time your memory will full. Okay. When your head is equal to 10, it indicates that your memory is full. Else, if here we are going to check a condition that looped is equal to true. Okay, looped is equal to true means we have to move from one memory location to other memory location, and head is not equal to true, then our whatever may be the memory of 10. See, we are going to use the reading, we are doing the reading, that's why here it is used the variable as 10. So memory 10 means first it will take memory of 0, then memory of 1, like this. So this memory of 0 content will be assigned directly. Okay. Then again it will check if tel is equal to 3 or not. If tel is equal to 3 means we have reached a memory of 3, means all the locations already we have read it. So if tel is equal to 3, again we are initializing tel is equal to 0 and looped is initialized to false. It indicates that all the contents we have means this looped is equal to false indicates that we have read the all the content of your the memory. Else you will increment the tel means tel 0, tel 1 means sorry, memory 0, memory 1, memory 2, memory 3 till tel is equal to 3. Okay. So in this way we are going to perform the read operation. Then for the write operation, if write is equal to 1 and again here you are going to check the condition as previously we have checked looped is equal to true. Now for the write you are considering looped is equal to false or head is not equal to tel, then memory of head is equal to data in means जो भी data in आएगा writing operation हम कर रहे हैं, that's why data in जो आएगा it will be assigned to memory 0, memory 1, memory 2, memory 3 like this. Okay, we can write the each location of your memory by using by sending a data to memory 0, memory 1 through data in. Right. Now again here we will check if head is equal to 3, then head is equal to 0. If head is equal to 3 आया तो head will be initialized to 0 and looped is equal to 2, else it will increment the head. Okay, means head is equal to initially 2 रहेगा तो head is equal to 3 तक वो increment करेगा and it will write the content from data into that memory 2 and memory 3 location respectively. Okay, so like this write operation. Else if the head is equal to 10 means your we can say memory is full. So in that case if looped is there, if looped is nothing but right now for full is equal to 1 indicates, it indicates that when looped is equal to full is equal to 1 indicates that we have performed the writing means looped is already यहाँ पे आपका ट्रू हो चुका है, यहाँ पे लूप्ड इज इक्वल टू ट्रू इन द सेंस लूप्ड इज इक्वल टू यहाँ पे 1 आया है. सो लूप्ड इज इक्वल टू 1 कब आया है, जब राइट ऑपरेशन में है. तो राइट ऑपरेशन कंप्लीट होगा इन द सेंस योर मेमोरी इज फुल. सो दैट्स व्हाई इफ लूप्ड देन फुल इज इक्वल टू 1 फॉर हेड इज इक्वल टू 10 if head is equal to 10. else your memory is empty, that's why empty is equal to 1. And if else that full and empty is equal to 0 indicates that now the reading and writing operation either of this is going on, means right now we can say it is, suppose it is performing some reading operation. Right now head is at 2 location and tail is at always at 0 location. So accordingly this 2 will be incremented. Okay, so till this head is till head is equal to 3, it will write the operation, write the data in, that is the content, it will take it from the data in and it will write it into the memory location till head is equal to 3. So that's why else here full is equal to 0 and empty is equal to 0, and then end if this is end process and end of your architecture. So in this way we are going to write the VHDL code for this 4x4 FIFO memory. Okay, now let us will write a VHDL test bench. So let us will write a VHDL test bench. To write a VHDL test bench, you have to just right click, say new source. Here you have to choose VHDL test bench. Here you have to give the name. Okay, and then say next, and it will show the summary of your the test bench name and say finish. So like this you have to consider the test bench. Right now previously the test bench is written, I will just open it. So what is that VHDL test bench? Everyone knows that entity without port declaration is called as a VHDL test bench. So this is the entity without port declaration, is nothing but your VHDL test bench. Okay, then in architecture it will consider this, all the ports will be declared as a component. Under the component declaration, this is component name, and all are here, all the ports are considered and end of your component. And all these, whatever may be the input mode of your signals are there, all these ports are considered initialized with your 0. You can say, see, clock, reset, read, write, data in. So this is auto generated test bench, okay. So wherein and those are the output signals, they are just declared here as a signal. Then you can observe here, we have assigned here the clock period time. By default they have given the 10 nanosecond is the clock period. Then begin, this is your unit under test, which indicates the component instantiation statement, means same signal with the same signal, that is same port with the same port is mapped here. Clock with clock, reset with reset, read with read, write with write, data in, data with data out, full with full, and empty with empty. Now here what is important role of us is that here for the test bench you have to write here in the stimulus process. This is your stimulus process. Now this is a clock process, wherein in the clock process you can mention, as here the above clock period is mentioned 10 nanosecond. So in auto generated it will mention wait for clock period by 2. So you have to just write here wait for 10 nanosecond, clock is equal to 1 and wait for 10 nanosecond. Okay. So this clock we have considered here. Now in the stimulus process, what is that? Always everyone knows that for a FIFO memory, while giving the stimulus, which is nothing but the input vectors. So for this, always consider that here is the reset, means initially we have to reset is equal to 1. It indicates that your data out will be initialized to 0, means whole memory is initialized to 0. Then you are going to wait for some time. This time should be means faster than the time which is mentioned in the clock period. Okay, that's why here it is mentioned wait for 50 nanosecond. Then we have reset is equal to 0 and we have provided the data in, which is equal to 0101, and then we are going to performing the writing operation. Then we will perform the write operation, then we will wait for some time, then we will perform a read operation. While performing the read operation, write is equal to is initialized with 0, means assigned with 0. Okay, and then this wait indicates is an infinite wait signal, and then end of your process statement, and this is your end of your the architecture body. Okay, within a, so here there is no name of your the architecture, because you can observe here, as this is your the architecture behavior of entity, this is your test bench. So that's why here we are not consider the end with behavior. Okay, so this is the test bench, that's why only the simple end is there. Now we will go for check syntax for this. So you will observe here in the console window that behavioral check syntax is completed successfully. It indicates that there is no any error in the test bench code. So is there any difficulty, students, in the test bench code for anyone? Let me know. You have to understood here that first you have to initialize your with reset is equal to 1, then you have to give wait command. Afterwards you have to reset with 0 and provide the data in signal with write operation. First you have to write into your the memory location, and then we have to read from your the memory location. So this is the sequence of your the asserting the input signal through the test bench is required for your the we can say the for FIFO memory. Okay, is there any difficulty to anyone? Let me know. All are clear about this test bench? Yes, please. Are you there, students?
Yes, ma'am.
Okay, thank you. So after behavioral check syntax, now I will directly go for simulate behavioral model. Now we will observe how is the simulation will be there. Now you can observe here that the simulation is done. You can observe here that I'm just moving. Yeah, you can observe here initially when clock is 0, reset is 0, read is equal to 1. Okay, and write is equal to 0. Read is equal to 1. What it indicates? You are reading the memory location, but we are not perform any writing operation. That's why we are providing a data in. Data in is available here on data in 0101, but you can observe on a data out. It is mentioned UUU, which is uninitialized, and full is equal to 0 and empty is equal to 0. Both are 0 indicates that we can perform read write operation, but because of this read we are performing here before writing, so that's why it is mentioned data out is equal to 00 and full and empty is equal to 000. Understood this? Because always in a memory first we have to write, then when only we can read from that your memory. Okay, so what is the next you can observe here that here is again a read is equal to 1. So means what happens here, as you know the queue operation, when we perform a write operation, during write operation you can observe here during the write operation, whatever maybe this data in is there, this data in will be stored inside to this buffer and will be available to the data out during the read operation. So you can observe here when clock is equal to 1, write is equal to 1, but again you are not getting the data out here. Okay, but during the reading operation when rising, now here the clock is getting here is 0 here, not 1. That's why even if your read is equal to 1, okay, you are not getting, it is uninitialized only. Now when we move ahead, so now you can observe here read is equal to 1, rising edge of your the clock is there, so data in will be available as data out. So in this way we have to simulate your the 4-bit FIFO memory. Is there any query to anyone? Now when it is read, then at that time you can observe empty is equal to 1. It indicates empty is equal to 1 indicates that now once all this data is read, then your memory is now empty. हमने all the locations read किए हैं, that's why empty is equal to showing it is 1. So clear for everyone? So in this way we have to simulate it using the test bench. Now same code you can modify it for the 8x8 memory के लिए. So 8x8 के लिए आप modify कर सकते हो. So you can do the practice at 8x8. Just we can say modify the data in and data out. Okay, so automatically it will change, and you have to change the variable for head and tail as 0 to 8. 8x8 के लिए आप change कर सकते हो. Okay, now let us we will go for next step. Simulation is done. Now we will go for synthesize. So I will just click on the synthesize. So and you will once the synthesize is running, now you will observe the RTL schematic and the technology schematic. Now you can observe first the RTL schematic. So I will just say this is the top level module for your RTL schematic, wherein all the input and output you are able to see. Once I will double click on this, you can observe here the internal gates along with your the mux you are be able to see. Only the gate and mux are the basic components of your the RTL schematic. Now you can observe the technology schematic. So this is the top model for your technology schematic. Now you can observe the technology schema. What is the technology schematic consist of? It consists of the lookup table along with the, you can observe these are the various lookup tables are there, and you can observe the various means specific. This lookup table is 4x2 lookup table. This lookup table is 4:1 lookup table. Okay, all this LUT stands for, this is a lookup tables. So in this way, it consists of input-output buffers with the lookup tables are nothing but your the basic components of your technology schematic, along with mux, which is nothing but the standard mux, that is 2:1 mux at the output terminal. Okay, so in this way we can see the technology schematic. So this is the technology schematic. Next one is we can go for implement design. You can go for implement design. Before implement design, you have to write a user constraint file, which is nothing but input output mapping, which I already explained to you previously. Okay, so you can write your own implementation constraint file, which indicates the mapping of your the input output names. That is nothing but you have to map a clock with clock, means write the pin number. Okay, so net name LOC equal to in double quotation you have to write P with pin names. Okay, so you can write the user constraint file, which is nothing but the implementation constraint file. Okay, and you can implement your design wherein it will perform translate, map, place and route operation, and you can just say generate a programming file. So it will generate your the bit programming file. Okay, now if you will see here in the we can say where the project is saved. So it is a FIFO memory. You will be able to see the bit file which is generated here. So this .ngc stands for technology schematic, .ngd stands for your RTL schematic. Okay, these are the files. Now you can observe here the .bit file is generated. I will show you. Yeah, FIFO underscore memory dot bit. So and this memory file you can interface it with the FPGA. You can connect the FPGA board, that is Spartan 3 XC3S400, and you can download this bit file onto your the FPGA device. So in this way we have to perform with this your the experiment for FIFO memory using VHDL. Okay. So if there is any query, you can ask your queries.